Client, server, and web-based database systems. Introduction. The following report provides answers to questions and provides examples regarding various aspects of client, server, and web-based database systems. Client-server security. In a client-server system, there are many standards that, when followed, will facilitate restrictions to sensitive information based on user access. Though this aspect is touted as a major benefit, in certain circumstances, security policies can be over-restrictive and the overall effect can reduce users' productivity and efficiency. For example, in my current job, our corporate security policies have become more restrictive for certain client-server applications that I use on a regular basis. I have lost access to certain information that certain groups within the company deem to be too sensitive. If I want to get the information on these restricted systems, I need to ask my manager to access them. Another example where security can be over-restrictive is eliminating a user's ability to download and install applications. The intention of this security protocol to mitigate risk of malware attacks is valid. Unfortunately, this can also reduce efficiency and productivity for both the user and the IT department. When a user needs to install software to do their job, but they cannot without administrator credentials, it requires assistance from an IT administrator. Furthermore, there are other less heavy-handed policies that can be used to mitigate risk to a network. For example, there are security applications that can be installed on all client PCs, providing an extra layer of security to prevent malware from getting onto the network. Client-server systems. A single point of failure. In a client-server system, data is stored on the server, and the clients access this data on demand. If the server malfunctions, all clients that attempt to access the server will fail to connect. This is considered a single point of failure. One of the software applications I support utilizes Microsoft SQL Server. Multiple client PCs can connect to the server that is hosting the SQL Server service. If the SQL Server service is not running, this creates a single point of failure for all users that are attempting to connect to it with an application. For example, this can occur when the server boots up and several services and applications attempt to start in succession. If there are not enough resources available for the SQL server to launch when the server is booting up, it will not start and will need to be started manually after there are enough resources available. This is a common issue I resolve on a regular basis. When to back up data. A general backup protocol for any system that is storing important data is essential, especially in the case of a client-server system where the data being accessed is needed on demand to complete important tasks from multiple users and clients at the same time. One of the applications I support in my current role is a web-based software that is used by water utilities to store and transfer water meter information such as meter readings and flow rates. The data from this system is also shared across other software systems to calculate water consumption and create invoices to customers. If data that we store on our system is not accessible, the water utilities would not be able to complete water bills and would not be able to generate their revenue. It is important to have a backup system for the web server so that if any issues arise, a secondary instance of the system can be quickly implemented, which limits the amount of downtime and ensures data integrity for our customers. In addition to creating a full backup for the data on the server, any local data on a client PC that needs to be accessed should also be backed up on a separate system so the users can ensure the integrity of this data. Examples of files that should be backed up from a local PC are pictures, spreadsheets, and other personal and business documents. There are many cloud backup systems that can facilitate backups automatically. This type of system is very user-friendly and makes backing up files simple and effortless. Scalability. Scalability is a term used to describe an information system's capability to manage an increase in the amount of data processed and number of users accessing that data. For example, an online banking application might start with 1,000 users when it first launches. As the bank promotes this application, they might need to support 1 million users or more in the future. This will require additional system resources to be able to process more data from more users all at the same time. If the system is not designed with scalability in mind, it will not be able to handle the increase in traffic, and it will have major performance issues and could crash. An example where scalability was lacking was the first launch of the healthcare.gov website. During the first few weeks, the system was not able to handle the number of users and transactions that were occurring. This resulted in the system taking a very long time to complete tasks, and some users were not able to access the site at all during certain peak times. If the system had been scaled properly, these issues would not have occurred. Back-end processor. The back-end processor is a system that processes data on the back end where most users do not have direct access. A common example of this would be a web server and all the applications and services that run on the server, such as a database information retrieval system. Another example of a back-end processor would be an email server. This system stores and sends all incoming and outgoing emails between devices such as PCs and cell phones and other email servers. Front-end processor. The front-end processor is the system that processes data between a back-end processor and a client. For example, a front-end processor can interface between a mainframe and peripheral devices such as printers and terminals. A front-end processor helps offload some of the data processing that would otherwise need to be performed on the back-end processor. Front-end processors are not as common today with the advancement of the internet and cloud servers, but they are still used in specific applications. For example, with industrial control systems, a front-end processor is used to manage the flow of incoming data from sensors and machinery to prevent latencies when users need to control multiple devices simultaneously. Web-based file sharing systems. There are many different products that provide a way for users to create and share documents with other users across the internet. I have personally used Microsoft 360, Google Docs, and Box. All these services offer similar features, but I personally use Google more often. Google Docs provides a great way for me to share files with my wife and other family members and anyone that has access to the internet. It also provides a way to control the security on all files, such as read-only access. I also use Box for my job. This is very similar to Google Docs, but it is a little less intuitive and limited in the range of features when compared with Google. I have been told that Box is trying to leverage its products as being a more secure form of file sharing. Since I do not share sensitive information such as my social security number or bank account on these systems, security is not my biggest concern. Client-side scripting. Client-side statements run on the client web browser after a web page has been loaded. One of the most common programming languages used for client-side scripting is JavaScript. For example, a JavaScript statement could be used to validate information that is entered in a web page form, such as a telephone number or email address. Without sending or receiving any data from a web server, the script on the HTML page can validate the information entered by the user and display an error message if the data that was entered is considered an invalid format. Another example would be a web page that provides a 3D picture of a product that a business is selling. The client-side statement could change the orientation of a picture in a web page based on how the user interacts with buttons on the web page. Server-side scripting. Server-side statements run on a server. These statements are used to connect to database information retrieval systems, access the files on a server, and communicate with other applications. Commonly used programming languages are PHP, Ruby on Rails, Python, .NET, Perl, and ASP. An example of a server-side script is a statement that inserts information that was entered in an online form, such as an email address and phone number, into a database on a web server. Another example of a server-side script is a statement that is used to complete an online purchase. One portion of the script could insert contact information into a database on a web server, and another portion could validate the user's form of payment, such as credit card or checking account, as well as transfer the funds from the user's bank to the company that sells the product.